So this is completely related to what you just finished working on, right? For the last whatever many minutes. Okay. Seth? Yes? Okay. So the goal today, can you determine the number of roots of a parabola or solutions from just applying this method? So what I want you to first look at is like think about the three different possibilities that there could be, right? So for quadratic relations, there's always, sorry, I gotta put this up. How about nobody says anything?
I was going to.
We're all staring at a blank board, nobody says anything.
I'm Canadian, I'm too polite to interrupt. There we go.
Okay? So for quadratic relations, there's three possible cases for the number of x-intercepts. Okay? I'll do the first one just because it's really easy. Okay? And that we've seen a whole bunch of them. Okay? I'll do the first one in black. So normally, like all the instances that you worked on today, they're, to my knowledge, because I haven't done the sheet, but there have been two, right? You get two roots, two roots, two roots, two roots, two roots, right? So you're always getting something that like has two x-intercepts, right? And then your question is, okay, I have two x-intercepts, but then your next question is it opening up or is it opening down, right? So they have two different kind of looking graphs, right? You can have one that looks like this, but you could also have one that looks like this, which is equally valid, right? So you can have two roots, right? Or solutions, whatever you want. You could pick one of those four words: roots, solutions, x-intercepts, zeros. One of those four words, right? They all mean the same thing. Okay? So if you get two answers from your quadratic equation, it looks like that, right? You know the parabola has to do something like that. Now, what happens if I get one root? What does that mean? Hayden? But there's only one root. So I'm going, there's one root.
Is it vertical line?
It's a very challenging question.
There's one root.
It only crosses the x-axis at one point.
The middle.
What about the middle?
Well, if it only crosses the x-axis at one point, then it has to be vertical because if it's
No,
vertical.
it can go diagonally through the middle.
Oh,
Let's just picture for a sec. Let's just draw one root on the x-axis and see what we have to do in order to create a parabola.
Plotted, it's fine.
I only have one root.
oh, it's going to be a sideways.
Is it sideways?
I don't know. Maybe.
Oh, just
Oh, we're done.
Or it could do what else? What else could it do? It
it
look
can
like
be a
that.
line.
No, it can't be a line. It has to be a parabola.
Oh.
It's the prerequisite for a quadratic. It has to be a parabola.
It can be side.
Those are your two options.
It could be
Or you could, no, it can't be sideways.
Oh.
Because it's not a parabola anymore. That's a root x function. Sideways parabolas are root x functions. We're not going to do, so forget about that. The only thing I cared about is a sideways parabola is not a function. That's what that came from. Right? So you could also have this. It could be anywhere along here, right? Right? Could have one solution. The point is what? The vertex, the maximum or minimum value, is on the x-axis. That's what matters. That's what's important. Right? Seth, you know what I said? Huh? Is what? What about it?
Chromatids.
Where is it located? On the x-axis.
On the x-axis.
Yes. Now, There is one more. Come on, guys. You gotta say something more.
Yeah. Did you
We didn't need it erased until now.
hand out that sheet?
Yes, sir. Okay.
Just keep checking your
Give you another one.
No, it's fine.
Okay. There's one more possibility. You got two. I got one. What do you think the last one is? 3.
1, 0.
We just did one.
Oh,
0 and then
0.
What's 0 look like? It's not on what?
0, 0.
0 zeros. I like that say. I'm going to write it down so much. 0 zeros. Which means what?
It's not on the x-axis.
That doesn't touch the x-axis anywhere. So what would the graphs have to look like? Yes, Hector?
It would either have to be like all the way, like the parabola would have to be completely in the negative or completely in the positive.
Okay, so it has to be, the vertex has to be above the x-axis and opening up. Or
Or below and open.
below and opening down. Okay, and I'll show you what we're going to do next is a little bit of the whole point of this is identifying which answers or how many roots should I expect to see from one piece of something. Okay, so you guys don't normally you can see like we did a whole bunch of these where I can see the number of roots from the equation written in factored form, right? So in this case, I would have 2 roots, right? One would be at x equals 1, and the other one would be at x equals 8, right? From this guy here. Right. And then here's my next question. Yes, Aiden, you ready? Let's hear for a sec. Okay, I'm gonna plot. I'm gonna go back to Desmos. Okay. What's the? I'm gonna plot this equation, right? So I'm gonna go 1/2. How many roots do I have for that?
1.
Just one. Why do I only have one? It opens up from the x-axis, and there's one key piece here missing.
There's not a coefficient.
There's a which Aiden?
Value.
Okay, yeah, I know what you're thinking. It's not C value though, because C values go with standard form. What form is this in? Factored,
Or yeah, factor.
right? So, which value is it? The Q value. And the Q value controlled up and down movements, right? So, if I took this parabola and I moved it down 2, now how many roots do I have?
2.
But what happens if I move it up 1?
0.
Okay. If there's no vertical movement, then it's sitting on the x-axis, and it has 1 root. Right? Does that make sense? Yeah, Ian?
So it's like a positive it's a positive, like the first number is positive and the last number is positive, not to be on. It's not gonna have any exit.
Right? So if your A value is positive, indicating that it's opening up, and your Q value is positive, that's indicating that it's above the x-axis and opening up. So there's no roots. I'll show you what that looks like in a minute. Not visually, but like with algebraically, right? Same thing's true if the A value is negative, that's indicating it's opening down. And if my Q value, so I've moved the parabola down, is also negative, then it can't cross the x-axis. It can't just imagine the arms just can't decide to swoop up again. That's a different function. Okay? So, we know, because we plotted this, we have one solution. Because the vertex, what's the vertex? Careful. -3 and 0, right? That came from the opposite of here, and then there's no Q value, so it's 0. All right? So then I can see, okay, well, that's on the x-axis, so there's one solution. Okay? The next one, what happens? A value is negative, and I moved it down. How many solutions do I have?
2.
Is it 2?
0, 0.
Let's plot it. Let's go plot it. We're going to go -2. Where is it? It just disappears, right? Where is it? I took it, right? I took the original, I moved it to the right 1, and then down 5. But it's also opening down, right? So then it's never going to cross the x-axis. So there's actually no solutions. Yeah. Yeah.
So solutions is just a different word for 0.
Yeah, so here these are 4 words are interchangeable. You can use these at any point in time. So if I write a question and I use one of these 4 words, they're all the same thing. Solutions, zeros, roots, x-intercepts. They're all the same thing.
How is there no solution for B? And what do you mean by solution? What are you trying to solve?
Solutions are like the x values that make the equation equal 0. So it's like, what value of x can I plug in such that my output is 0, or the y value is 0, right? So Jessica, on this graph, a solution, I'll change the equation so that we have solutions. A solution would be these two right here, right? Solutions, x-intercepts, roots, zeros, all interchangeable, right? Okay? So, I'm going to show you something. Okay? Some of you may have already seen this before. This fancy word, which I should have introduced in 2 there, but for the interest of time, I don't want you to type this in, okay? Or do this, because we've already done 40 of them today, or should have, or done a few anyway. I'm just going to show you the shortcut. So there's this special thing, and some of you have realized, right, that sometimes I get a negative number underneath the square root, and then you're like, did I do something wrong? Like, what's going on here, right? Turns out if you truly get a negative number underneath the square root, then there's no roots. It breaks the equation, which then indicates that you're in this scenario. Okay? Does that make sense? You want me to repeat that? So if you get a negative number under here, it physically breaks this whole thing down. In which case, it doesn't work, and it doesn't work because there are no solutions or no roots. It does not cross the x-axis. right? So the interesting part about this is if I look at just that piece alone, I can tell how many solutions the quadratic has. We call this the discriminant. It's a fancy word. Okay?
Sounds like a
So if, let's just say here, I'm only worried about this. Okay? Now, you're going to plug in a number, or plug in the values, and you're going to get a number. At which point you're going to interpret that number and come up with a conclusion about the parabola. For instance, remember what's out front of here, a plus minus. That's important in order to make up a decision. Right? So, for this one, I'm going to plug in the b value. It's -8, so that's going to go there. The a value is -3, and the c value is 1. Right? So I'm just going to plug those in there. -8 squared minus 4 multiplied by -3 by 1. So you get 64 minus -12.
Would it be positive since the negative?
Yeah, yeah. Say that again, sorry?
Wouldn't it be positive since the -4?
Yeah, I just want to show everybody, because a lot of times, like, people forget about what goes on in here, right? So they lose track of the number of negatives that exist. So I just do it this way so that we can see, right? So now I have two negatives sitting here. That looks like an equal sign now, right? I have these two negatives, right? They turn into positive, so I get 64 plus 12. Right? So, if you go back to the original quadratic equation, I get a number underneath here now, right? And I can take that number and I can both add it and subtract it from the b value, right? So I'm going to get two answers for x. When I go to solve for the roots, I'm going to have two of them, right? Because I'm going to have a -b minus 76, and I'm going to have -b plus 76. Yes, Aiden?
Is this a different equation than the quadratic?
Nope. It's just one piece of the quadratic equation.
So you just got rid of the negative
Yep.
at the start and the divide by two.
This is just for answering the question of how many roots exist, not what they are, how many.
Okay, so you don't need to.
No, I don't need. So if I asked you how many roots exist for this parabola, you'd use the discriminant or just that piece under the square root, because that's what's controlling the entire thing.
Oh, this is the discriminant.
This is the discriminant, right? So this is just telling me how many roots exist, not what they are. So you don't need the whole thing. Aiden, yeah.
We were in Hawkins class when we were looking at discriminant. We only did b squared minus 4ac. You did the plus minus squared.
Yeah, all without the square root?
Yeah.
Okay. That's why I'll explain that in a sec. Okay, so you don't need the square root. For the reason, I'll explain it down in the next piece. So is it on the? So you turn the page over. Okay, is everybody okay with that? So we'll go to the next page, and I'll come up with the rules. Aiden, I put the square root there because then you can contextually see. You'll see if d. So this is the discriminant. D is equal to that, right? If I get, let's start at the bottom because the bottom's really easy. What does this mean?
D is less than 0.
Which is another way of saying what?
D is a negative number.
If d is a negative number. So if I get a negative number under here, Aiden, what happens?
That's going to be a positive.
You get a negative number underneath the square root. What happens?
For what?
Right here. It's negative, but I can't square root a negative number.
You get 0 points.
You don't get any points.
You get not applicable. Can't work.
That's just the answer.
You're just going to look at it and you go, okay, well, I'm going to get a negative number in there. I can't square root a negative number. That's why I leave the square root there. Because now it means something, right? It adds another layer of understanding, whereas if you don't put the square root on there, then everybody's just like, that is just a set of rules. If the square root's there, then you can kind of go, I understand physically what's happening, right? Something is breaking down if I get a negative number, therefore I don't have any roots, right?
So if it is a negative, then you just throw it down.
0, no solutions. Because you can't square root a negative number. Right? If I were to just to write b squared minus 4ac, and that if it's negative, then there's no, that's just a list of rules now. Right? Not really about lists of rules. I want to show you like why, like, right? Why is this breaking down?
The discriminant is b, right?
The discriminant is the whole piece underneath the square root. The discriminant is this. But if I put the square root over top, and the black piece is negative, I can't square root the black piece if it's negative.
So there's no.
There's no solutions. Right? So now, you can, but you don't care what it is. Because all I want to know is give me a number of solutions. I don't care what it is. Right? I want to know which of these 3 pictures is it. That's what the discriminant's doing for you. So if you get a negative number underneath for the discriminant, it's this scenario. Right? You've broken it because you can't square root. Right? So let's go to the next one. If d is equal to 0. Yes, Jessica?
Choose 1 point.
Why is there 1 point?
Because the y value would equal to 0, so it would tell you that. Oh wait, no. Wait,
What are we finding? X values, right?
Yeah.
I think
So-
you said y.
Yeah, so the second x value would equal to 0.
Hey, you guys watching? I don't want to do this 4 times.
The second x value would be a negative number, or it would be equal to 0, so it's not applicable, therefore you'd only have 1.
Okay? If this piece here is 0, it basically disappears. What do you get? You get negative b plus or minus 0, nothing, divided by 2a. So you just get one answer, right? Because basically your answer is just negative b over 2a. That's your root. Because there's nothing, there's no square root, no plus minus, like you can't do anything with that. Because it's 0. Therefore you just get one number. Negative b over 2a. One solution. Right? And then you know, okay, well the last one must be, if I get a positive number underneath the square root, now I can add that number and I can also subtract it. So then I get 2 solutions. Does that make sense? Okay, so you just plug in values and you see how many solutions you get. Right? Okay? Everybody good?
Yes.
Okay, so you can try a couple of those questions there, and I'll give you the sheet, and then we'll pick up from there when we come back